Here's a couple of challenges with rational functions. So the challenge is, can I figure out a significant amount of information from this graph prior to graphing it? So again, we're working on extracting as much information as possible from the equation. So number one thing I always say is factor. You need to be able to factor these. So this, excuse me, this is negative 2x minus 8 over 4x minus 12. All right. And what I've done is I'm going to go ahead and factor it. So both the numerator and denominator have a greatest common factor. I factor out a negative 2 from the numerator and a positive 4 from the denominator. I've already verified these are correct graphs. Okay. And now what I'm going to do is let's see what I can find out. So first thing I'm going to note is anytime I factor, I like to go ahead and notice what the zeros are that would accompany those factors. So negative 4, for example, will make this factor equal to 0. And then positive 3 is going to make that the denominator equal to 0. Okay, so I know that let's start with negative 4. The zeros of the numerator possibly give me the zeros of the denominator as the zeros of the numerator give me the zeros of the function, as long as it doesn't overlap with the 0 of the denominator. So there's no overlap here, no common factor, common 0. So that tells me that negative 4 is going to be an x-intercept for this function. So I'm going to go ahead and plot that, all right? And I would invite you to do this on graph paper, all right? The next thing, so that checks the whole x-intercept thing, all right? The next thing is, how about this 3? Well, this 3 is a discontinuity. It does not have a common 3 as a 0 in the numerator, so this 3 must be a vertical asymptote discontinuity. That means that at positive 3, which is here, I'm going to have a good old vertical asymptote. All right, so I'm going to go ahead and plot that. Loving the lag that this thing has. Not. Let me move my face. All right, et cetera, et cetera. How about right here? All right, and let's see. I am just drawing my good old asymptote at positive 3. All right, that should take care of it. So vertical asymptote, check. How about horizontal asymptote? Well, horizontal asymptote, since this is a linear divided by linear, anytime you have equivalent degrees, you look at the ratio of the leading coefficients. So the ratio here, leading coefficient is negative 2, leading coefficient is 4, so that ratio is negative 1/2. That means that this function should have a horizontal asymptote. It should have a horizontal asymptote at negative 1/2. So this is negative 1, this is negative 1/2. That means that along this horizontal line, please forgive the lag. All right, along this horizontal line. And so what I'm doing is I'm basically constructing a backbone for this graph because I have a good understanding of the equation. All right, that should be the horizontal asymptote. So I'm going to cross that guy out. All right, y-intercept. So if this graph is to cross the y-axis, which it should, there's no asymptote at the y-axis, where would it be? Well, we look at the ratio of our constants. So the ratio of negative 8 to negative 12, that's 2 to 3, so 2/3. 0 2/3. So this is 0 1/2, 0 2/3. So 0 2/3 is going to be about right here. All right, right here. And I'm going to make it extra bold just to make sure it actually crosses there. All right. And that's that. So we took care of the y-intercept by looking at the ratio of the constants. And do we have a hole? Well, there's no common 0 in the numerator and denominator, so there's no hole. And so basically now we've predicted this information. All right, and let's check it out. If we actually graph this thing, we'll cross your fingers and boom, how about them apples? That's fantastic. That's one of the greatest things I've seen all day. Okay, so there you go. That is how you connect the equation to the graph, and we predict many of its features. Not only do we predict, right, because a lot of times you're just going to graph these, we understand the features. Now we should know where these features come from. All right, and that is how you graph that. All right, very good. Next. Silly some more.